Today we're going to take a look at the address calculation sort. Now, address calculation sort is a sorting method that works similarly to bucket sort. It basically takes an array and it divides those arrays using a hashing method into various addresses, which are basically like buckets. And when it does that, this is how it differs from bucket sort, is it uses an insertion sorting method to actually insert those data sets into the address in sorted order. Then once it collects all of the addresses from the starting array, it will replace the starting array values with the address book values that are already in sorted order. Now, to kind of make this sorting method more efficient, I've built two classes. I'm basically going to use a linked list instead of an array to hold the addresses. So my address table is going to be an array of linked lists rather than an array of arrays. So we'll take a look at the base class. The base class is just a node. Again, it just holds data, and in this case numbers, and a pointer to the next node. Then we build up our linked list, and this is a very simple linked list. The only thing it contains is the initialization method, which basically just sets the head of the linked list. An insert method. Now this is where we do our insertion sort for our linked list. So when it takes in a new node, it checks to see if there's anything at that address point. If not, it makes that node the head. If there is, however, it does an insertion sort. Basically, it just asks to see whether or not the data is comparable to what's at the current data. If it's less than the current data, it inserts it before the node. If current is head, it makes the new node the head, and current the next node. Then I've built in a print. Now I've built in this print method basically just to show what the address table looks like. I'm going to leave this here in the linked list method, but when we get to our address calculation method, you'll see a print there, and with a statement, a comment that says remove before submission. Probably just going to comment that out, but it will allow the user to print the table so that it's visible, so they can see where everything goes in the address table. Alright, so the next method is the address calculation sort. I've required relative the node in the linked list. This is just so that we can use these classes in our method. And we'll get to it. So the address table that's built in this address calculation sort, the address calculation sort builds or takes in an array. Then it creates an address table. Now the address table is basically the size of whatever size we're passing in. Now I set a constant equal to size 11, and the reason I do size 11 rather than a typical size 10 is because I'm going to create a bucket for negative numbers, or a table address location for negative numbers. Negative numbers are difficult to handle when you're inserting them into an address or a bucket, because it's difficult to find a bucket to place them in using a negative index. Again, we are looking at negative numbers, but we need to place them into integer labeled indices, and it's just easier to deal with the negative numbers together. And because we're using an insertion sorting method, when we add those negative numbers into the table, those negative numbers will come into the table in order. So we won't have to deal with that portion when we get to the end. Now, I didn't want to mutate the array that we're passing in, so I went ahead and created a temporary array, which is just duplication of the original array passed in. And again, this is just avoids mutation for the original array. That way, if we need to do anything with it, we can. Then I'm going to hash each of the values in the array, in that temporary array, into the address table. And I do this using a hash function. So if we scroll down a little bit to take a look at the hash function, it's a very, very simple hash function. Basically, it asks if the number is greater than 0, the number passed in. If it is, then it's going to hash that number. It's basically just going to divide the number by the size of the table and then add 1. If it's less than 0, then it's just going to hash the number into address table 0. So again, a very simple hash function. Once that occurs, it inserts the number into the table at the address that was returned from the hash function. Remember, all negative numbers are going to be hashed into the 0 address. Now, the next method is the next iteration is the print. And basically, I didn't build it as a function, although I think I'm going to take this out after this video and create it into a function and just say, hey, print this off, which is actually fairly simple. Let's go ahead and do that real fast. So define print table, and then we're going to pass in an array. We'll just say we're passing in the table, and then go ahead and copy all of this, cut it, and print it in. And okay, so then we just have to print the table when we are done. So print table, and this is going to be the address table. It's going to be passed in here. Okay, so now that that is done, so we're passing in, or we're printing the table. Basically, this is just going to show all the numbers as they sit in that address table. And then we have to actually move the address table into that temporary array at the appropriate indices. So we're setting index equal to 0, and then from 0 to size, again, remember that's the size of our total array, we're going to iterate over this, and we're going to set current equal to address table I head. And basically what this is going to do is going to take that linked list, and every value in the linked list is going to be passed into the temporary array at the index from the index value here. When a value is passed in, basically until that address reaches nil, or that linked list reaches the end, it's going to pass in the data into the temporary array at the index that we're looking at currently. Then it's going to increment the index and continue on to the next value. And it's going to do that for every single address in the address table. If an address doesn't contain any data, it moves on to the next table, obviously because the current is nil. And then once it's finished with that, it's going to then print out our sorted array. So let's go ahead and see that in action. So hopefully that print table method works. If not, we'll just revert and then build it up before I turn it in. So let's do Ruby spec, and then it's address calc sort.rb, and I figured that there would be an issue with that. And there we go. So the random array passed in are the numbers here. And again, when I do this, I do it similarly to every single method. Basically, I create a shuffled array of random ranges, and then I pass that in, or I print the shuffled array, and then I print the sorted shuffled array. So random array is 34, 90, 26, 82, 11, 37, 43, 45, 28, and 23. Here's my address table, and then my sorted array. Notice no negative numbers were there, so let's run it again. Well, we have 0 here this time. One more time. Okay, so we can see that it handles negative values as well. Then we'll do the rspec. And 7 examples passed in, 0 failures, and we are done. Again, if there are any questions or comments,